All right, hello everybody. This is the Unit 7 review. It covers, excuse me, this is for the multiple choice test that's tomorrow. It's going to cover a lot of questions from our 7-1 section and then some questions from 7-2. As we go through this review, you might want to jot down notes on an index card. You will be able to use your index card on the test. So let's go ahead and get started. And this is your very first question. Most of my students, hopefully, will remember this or how to answer this question from their algebra class. If you get this wrong, it's because you mess up and forget that the numbers in parentheses represent your x values. Okay? So in this case, we are looking for f of 8 minus f of 2. So we want to know f of 8, what does f of 8 equal? And if you look right here, when your x is 8, your y is 40. So f of 8 equals 40, and f of 2 equals negative 40. All right. So the biggest thing, make sure you realize that the numbers in the parentheses are your x values and your y values would be the f of x, okay? So in this case, we have 40 minus a negative 40. So what you end up doing is adding those two together, and the correct answer is 80. Okay, don't forget how to find your y values, okay? This question, what are the solutions to the equation x cubed minus 7x squared plus 12x? Well, if you pull up your graph on the calculator, all you're looking for are x-intercepts, okay? In this case, you have 3 x-intercepts, excuse me. You have one of them when x is 0, one when x is 3, and one when x is 4. So your solutions there would be 0, 3, and 4. If on your test it says what are the factors, then your factors are going to be x minus 3, and x minus 4. Okay, notice this question asks for the solutions. So when it's the solutions, you just look for your x-intercepts, and whatever the number is, that's the solution. If you're looking for the factors, you would set up your equation in factor form. Again, you would first find the x-intercepts, so 0, 3, and 4, but then you need to switch the signs. So the positive 3 x-intercept would become x minus 3. The positive 4 x-intercept would become the factor x minus 4. And then for x minus 0, that just equals x, so you would have that factor, okay? Let's look at another one. Which of the statements below describes the end behavior? Remember, this is from 7-1. Your leading coefficient tells you what the right side of the graph does. And then your exponent, your highest degree, tells you whether the left side is going to match the right side or if it's going in opposite directions. So for this one, you need to remember, you should be able to do this or answer this question without even graphing it, because your leading coefficient is negative. Then a negative leading coefficient makes the right side of the graph decrease or go down. Okay? So we know that in this case, let's see, the right side of the graph is decreasing. With these, you need to understand what all this means. And this is the math shorthand. And then I have it written out in longhand, I guess, or in words. All right. So here, your negative leading coefficient makes the right side decrease. If you have a positive leading coefficient, the right side is going to increase. And then because our degree is 5 and 5 is an odd number, then the opposites, or excuse me, then the end behaviors will go in opposite directions. So remember, if you have an odd exponent, your end behavior is going in opposite directions. If you have an even exponent, the end behavior, they're going to go in the same direction, okay? So whether your paper on your test, whether you have an even or odd leading coefficient, sorry, not leading coefficient. If you have a negative or positive leading coefficient, that tells you what your right side is doing. And then if your exponent is even or odd, that tells you whether the left is going to match the right or if it's going to go in opposite directions. All right, with this one, which type of function would best model the data? There's a lot of ways that you can do this. No matter what, you are going to want to, going to want to go to the spreadsheet on your calculator. Okay, once you get to the spreadsheet, make sure you label your columns first and then fill out the columns. Okay, you have to have your columns headings labeled and then fill out the columns. Then there's a couple ways to do this. If you want to, you could have the calculator give you all the different types of functions, like you can have it give you a linear function or quadratic function or cubic function or quartic function, or you can just look for the quick graph, okay? If you get all the different types of formulas and compare the R values on which one is most accurate, you could do that. It's really time consuming. It's easier to look at the graph and see how many bends you get. All right, so if you are doing the quick graph, then after you fill out your rows and your columns, you have to highlight one of the cells. It doesn't matter which cell you highlight, but one of them that has data in it. Okay, once you get that done, then you're going to, hold on, let me move these out of the way. Okay, once you do that, you're going to go to Menu, Data, and Quick Graph. That will give you a graph that looks like this. Okay, you will have to tell the calculator that the x-axis is the x-axis and the y-axis is the y-axis. Okay, once you do that, the graph you get will look something like this. Okay, and basically you need to go through and say, okay, if I connect all the dots, what does my graph look like? And you don't have to be super precise. Basically, you're looking for the number of bends you're going to have, depending on your test will determine what your graph would look like. So if our graph looked like this, there's 2 bends, so this would be x to the 3rd power, which is a cubic function. Okay? If you have points that go in that shape, it would be x squared, which is a quadratic function. All right, and then let's say you had a graph that looks like this. You have 3 bends, so it would be x to the 4th power. Remember, you count the bends and you add 1 to determine the degree. And then that type of graph is called a quartic, Q-U-A-R-T-I-C, okay? On the test tomorrow, your multiple choice options are going to be linear, quadratic, cubic, or quartic, okay? You need to remember quadratic is x squared, cubic is x to the 3rd power, and quartic is x to the 4th power, all right? All right, so for this one, hold on. Sorry. Graph the function and then answer the next 3 questions. So what are the x-intercepts? Well, this one only has one x-intercept at 1. Okay. Then let's skip number 6 for now. What are the y-intercepts, or what is the y-intercept? It looks like it's approximately 3. For this purpose, we're just going to say it's at 3. And then they want us to find the relative minimum and maximum. Okay, I didn't change my graph. So I went ahead and searched for the graph. when you analyze your graph, okay, so menu, to do this you need to do menu, analyze graph, and then find maximum and minimum. So here's your minimum, here's your maximum. Here, your minimum is at, you're going to have coordinate points for that. Don't just write down your x and leave it at that. You need to have both of them. Your minimum is at negative 0.86 and your 1.93. That's your x and your y coordinates. Your maximum, looks like I didn't show this graph enough. So your maximum is at right here at 0.194 and 3 point something, 3.1. Okay, make sure you know how to find the minimum and maximum, and make sure you know which is minimum and which is maximum. All right, next one, the volume of the box can be found with the volume function, where x is the length of the shortest edge of the box, and you have that equation, what is the length of the shortest edge of the box if it has a volume of 30 cubic units. Okay, with this, again, you can graph it. On here, your x-axis represents the shortest side. It's the shortest side of your box, and the y is the volume, right? Okay. In this case, when you first graph it, you really can't see anything. Okay. We want to know the x when your volume is 30. So we need to go ahead and graph. There's two formulas you need to graph. In this formula up here should be graphed in f of x, f1 of x, and then for f2 of x, you can see it here. It's going to be just graph f2 of x equals to 30. The reason why I picked 30 is because the 30 is right here where we're looking at that volume. Okay, you'll notice that when you do that, you probably won't see it on your calculator screen unless you change the y max. Notice here my y max, I put my y max set to 40. Why did I choose 40? Well, because it was a number greater than 30. So whatever your test question is set to on your, over here on your volume, that's what, you need a number greater than that. All right, and then notice we have 3 intersecting points here, here, and here. Which one do you want? Well, for this problem situation, we want the positive, the first positive solution that's right here. Okay? When we plug that in, we find out that we get a volume of 30 when our x is 3. All right, another question. I'm tired. All right. So in this one, we need to create the equation. They give us the size of the cardboard, and we need to create the equation to find the volume of the box. Okay, this is very similar to when we were cutting out boxes a couple weeks ago. Okay, and the x equals the corner measurement that we cut out. So in this case, our height of the box was our x. Our length and our width we had to calculate out. Well, if the biggest side is 13, then to calculate our length, we'd have 13 minus 2x. The reason why we had 2x's is because we're taking off x from both sides, so we're taking off 2x's. And then our width would be 8 minus 2x, because again, we're taking off 2x's on the width. But when we do that, or when we set up our volume formula, v of x, we would get x times 13 minus 2x times 8 minus 2x, okay? Now, so that's our equation in factor form, but your multiple choice our options are going to be in polynomial form. So you have to multiply all those together. I'm going to let you multiply those out on your own. You can either FOIL it or box it, or you can distribute it. Just so you can check your work to see if you've done the equation correctly, I will write the answer on the board. You'll have 4x cubed minus 42x squared plus 104 times x. Okay, that's the final answer you should get. If you need to, pause the video, do all the work, and then check your answers. Okay? Alright, next one. If the only x-intercepts of a degree 5 polynomial function are at -1, 0, 1, and 3, then what is true about this function? It has 4 x-intercepts. Well, in the statement, we know that the only x-intercepts are -1, 0, 1, and 3. So how many x-intercepts is that? Well, it's 4. So this is definitely true. The next question, or the next statement, f of 5 equals 0. So how can I know whether that's true or not if I don't even know the equation? Well, if 5 was an x-intercept, then when I plug it into the equation, it will give me a 0. Is 5 one of these x-intercepts? Okay, those are the only x-intercepts I have. Because 5 is not one of them, that is not true. Now, if the statement said f of -1 equals 0, then it would be true. Okay, if it says f of 3 equals 0, that is also true. But it has to be one of these x-intercepts in order to make that equation equal to 0. All right, now part 3, or option 3, is it does not have a double root. Okay, so let's count all our solutions. We have 1 x-intercept, 2 x-intercepts, 3, and 4 x-intercepts. I should have 5 solutions, but because I only have 4 x-intercepts, that means one of my x-intercepts has a double root. Okay, the reason why I know it's a double root is because the only other option is that the solution could be imaginary. But imaginary solutions have to come in pairs. So I can't have just one imaginary solution. And since I only am missing one x-intercept, that means that one of my x-intercepts is a double root. So in this case, I have 4 x-intercepts, and one of the x-intercepts is a double root. Okay? All right, let's go through the rest of these quickly. In this graph, the leading coefficient is positive. It's a degree of 2 because I have one bend, its degree is 2, and I have 2 x-intercepts. I have no double roots, and I have no imaginary solutions. Okay, here's another graph. In this one, again, my leading coefficient is positive. I have 3 bends, I have 2 bends, so my degree is 3, which means I should have 3 solutions, but I only have 2 x-intercepts. And notice this x-intercept right here. Because the graph hits the x-axis and then bounces off, that means I have a double root right there. So I have one double root, and I have no imaginary solutions. Okay? By now you're probably saying, well, how do you know if you have an imaginary solution? Let's look at this one. Here your leading coefficient is negative. Your degree is, 1, 2, 3 bends, so my degree is 4. And I have 2 x-intercepts. I do not have any double roots. Notice both of my x-intercepts are crossing the x-axis. Okay? Because my degree is 4, I should have 4 solutions. Okay? However, I only have 2 x-intercepts. So what's 4 minus 2 is 2. Because I have no double roots, the only other option is that I have two imaginary solutions. Okay? So first look at the degree. That will tell you how many solutions you have. Look at the x-intercepts. Check and see if any of them are double roots, and then however many you're missing after that, that's how many imaginary solutions you have. All right, last one. This is a crazy graph. I drew it just for fun. Your leading coefficient is positive. Your bends are 1, 2, 3, 4, 5, 6 bends. So your degree is 7. So we need 7 solutions. Okay, how many x-intercepts do you have? Let me change the color. We have 1, 2, 3, 4 x-intercepts. One of our x-intercepts is a double root, so that's a total of 5 solutions. We should have 7, so that means 2 of my solutions are imaginary. All right, there's the end of the review. Hopefully it wasn't too hard. Hopefully you remember all this stuff. Make sure you fill out your what? Make sure you fill out an index card and bring it with you to the test. You can use it. All right, see you tomorrow.